Hello everyone, welcome back. My name is Marcos. Let's continue our journey to learn Go. In today's episode, we're going to take a look at recursion, pointers, and the last but not least, strings and runes. Let's go. Before we start, as usual, let me just say that the content we have been using here is coming from the website called goesbyexamples.com. The link will be on the description below. It's an amazing website that allows you to study Go with examples, and we have been using this material. It's amazing. Please take a look on their website. So let's start. Recursion. So there's not much to say syntax wise when it comes to recursion in Go, just because recursion is not necessarily a syntax specific thing, but there is a very specific detail that I would like to show you. But yeah, as usual, once again, I have here on the right side my terminal. I'm going to take a look if I have any additional changes on this repository, which I do not. I clear this. And let's execute the code, and then we're going to go top to bottom. So I'm going to go to the examples folder and recursion. Here we go. Any order to run is go run dot. Which is just run the main package. And here we go. We have two outputs. We have two numbers. Let's take a look at what actually means. Here on the top, it just mentioned a Wikipedia website for recursion in computer science. So please take a look if you want to. So here on the main function, we do a print line, and there is fact for factorial. That's a mathematical function here, which typically speaking, we do that in programming using recursion. So right here, the recursion syntax, there is nothing special, as we can see here. Just is a standard function which has a name, a parameter, and returns a type. As any other recursion function, you gotta have the exit condition. So in this case, the exit condition is if you reach the number 0, then you return 1. Otherwise, you're gonna take that number times factorial, your parameter minus 1. And that's exactly what we print here on the very first time. And the result, the fact 7, the factorial for number 7 is 5040. Nothing fancy there, right? So what is the most important here, which is a connection to the previous episodes that we took a look on functions and closures. If you haven't watched, please take a look on my video there. But what it actually means here is the next one will be a Fibonacci sequence, once again, done using recursion, but the difference is we are using function closures. And the idea of the function closures is you have the ability to, within the function, to take a look on the previously defined variable, right? So let's just go one by line here. We have we define first as a variable the Fibonacci sequence function, right, inside of the main. And when we do this, we do an equal sign. We are specifying the actual function itself, and we do the logic, like if it is less than 2, then you just return. Otherwise, the Fibonacci sequence is the previous 2 values, plus sign. The catch here on the closure thing is this guy right here. So on the line 33, you're calling the Fibonacci sequence again, which is a variable that has been declared on line 26 here, right? And what is trying to explain to you here, it works as long as you declare the function beforehand. If you do not do that, it's not gonna work, right? So right now we just run the code. So just to be a little bit more clear, if I comment this, and then I do a colon here, an equal sign, it's a valid Go syntax, right? So if you mouse over here, you say, hey, this is a variable that is a function that accepts one parameter and returns the integer. However, when you go mouse over here on the 33, you're gonna say, hey, this is actually undeclared name, because Go requires you to have that, declared beforehand in order for you to access that variable, which is a function. So that's essentially it for recursion. Nothing special here. Be careful with recursion. There's a lot of applicabilities, and I like it when it is well used. Just be careful with the complexity and with the function closures. And that's pretty much it for recursion. Next, we're gonna take a look on pointers. Pointers, let's go. Okay, so first we're gonna go here on the one folder up, and then we're gonna go to pointers. Here we go. We're on pointers now. I'm gonna clear this. I can actually close the recursion here. It's fine. And then go here to pointers. As usual, let's run it. Let's run it, right? So go run dot. Let's see what's the output. We have a few outputs here. We're gonna understand in a second what actually it is doing. So first of all, pointers. The idea of pointers is you either are using modifying a variable. If you have a variable, you can modify the value right away, or you're modifying the variable at a specific location. So the pointer is, instead of you pointing to a variable, you're actually pointing to the address of that variable, so you can modify it, directly. There are some nuances here, but let's just continue. So for example, at the very top, we have a function being declared. On this function, nothing special. It's just called 0val, which is you pass a parameter, which is an integer, and you assign that parameter to 0. Doesn't matter what is being called or what the value being passed. You're always gonna equal sign 0 here. And there is another function which has the star sign at the beginning, and this is the syntax for pointers in Go. The difference is, if you mouse over, you actually see the difference. There is a star integer there, and same thing here. So the difference is you're not modifying the value. You don't have a copy of that variable. Instead, you're modifying whoever called this. If it uses a variable, it's modifying the memory address of that variable, and there is a difference in execution. So for example, here on the function main, we have an I, which is equal 1, and we say initial I, right? So we got the value 1 here. And then there is 0val. Remember, the 0val is you specify you're passing the variable I, but inside of the 0val function, you're assigning 0. But right after that, we print the value, and the value actually continues to be 1, because within the scope of function main, the value I, the variable I, is actually 1. It has not been modified. So when it goes inside of 0val, because just as a standard variable, Go creates in an additional copy, creates a copy of those parameters, right? That's the default behavior anyway. Now, instead, if we want to call the 0 pointer here, what it does do, it accepts an address, right? So the syntax for Go, when you because you declared I as a standard function, is not a pointer. If you want to specify, hey Go, you need an address, then the the letter n sign here is the syntax to give the memory address of the variable I. So when you do this, then this actually becomes a pointer. And the difference is, you can see here is 0 the value, right, of I, and then when you try to print within function main, within this scope, you see that the value has actually been modified. It is important distinction here in Go that makes it very explicit in comparison to other languages, like for example C#. They don't have pointers explicitly, like they added the capabilities later on, but the idea is they have this distinction of specific variable types are value types, specific variable types are reference types, and they behave differently. So sometimes if you pass a variable by parameter, will modify on the parent, sometimes not. Very confusing. I don't want to go in detail. I'm actually planning to release a video about the differences between C# and Go. I'm proficient in with C#. I've been working with C# for 15 years. But yeah, so the idea of having a little bit more explicit is actually better. So yeah, so that's pretty much it here. And last but not least, a pointer, if you actually print the E sign, the N sign here and the letter I, you're gonna see the actual value of that pointer. So this is the hexadecimal representation of the space in memory that variable is being stored. We don't use this as much, in terms of printing, but there might be some cases if you need to do some troubleshooting or some weird behavior, you might use this, but it's good to see it, like what actually it means. Another thing is pointers is used a lot in Go for, better memory management and some other things, or if you have a function that you indeed intentionally want to change the value inside of that function, you're going to use a pointer. So I remember just in an additional comment, back in the computer science days when I was having my degree, the concept of pointers, when we learned using like C and C++, it was vague and hard to grasp. But I assure you, once you started seeing the benefits of like changing the value intentionally inside of other functions or not, it becomes very handy. And yeah, that's pretty much it for pointers. And let's go to the last part of this video, which is going to be very exciting, is strings and runes. Okay, strings and runes, let's go. String and runes is going to blow your mind when it comes to this Go implementation here, right? So as usual, let's close pointers here and we open the strings and runes file. I'm going to go one folder up, see the strings tab here. Here you go, let's clear. As usual, once again, let's run it, and you see there will be a lot of output because there is a lot to cover, right? So before we read in the code, let us take a look on a few definitions first, right? So the concept of characters. The character, it is a human perceived unit of, a representation of a symbol, right? In this case, a symbol could be a letter, but it could also be an emoji, or some other languages, such as, languages from Asia, continents, they have, specific symbols that represents entire words or even sentences, right? So, but the idea is if you have a unit, we usually call that characters. But in Go and in other programming languages, you have this concept of a string variable. If you want to see each unit, you're just going to iterate through the characters, right? But in Golang, a string is actually a slice of bytes. That's it, right? So let's keep that in mind. But there is a few other things and a few important readings that I'd like to recommend. It will be on the description below, all those links. And it's also actually here as well. But let's just take a look here. So at the very first, on the function main here, we are declaring a constant called s, and there is unknown to me, but this is actually Thai. The Thai language is hello in Thai. Cannot read it, cannot pronounce it. I apologize about that. But it is nice that they chose a different language to just make it explicit on how important the distinction of a character and how Go works. Let's continue, right? So we have this const here, and the common sense in some other languages, if you specify the len, meaning like the length, the size of that string, you would expect to return, 4 in this case, right? Like in a character, humanly perceived unit. So 1, 2, 3, 4. But if you see the output here is actually 18. Why? Because as here, a string, it is, remember, is a slice of bytes. So when you do the len, you're actually returning the amount of, the array of bytes of the slice, and the actual amount here, which is 18. And they go even further. In one step here is actually they do a for loop, right? So a for loop here, you have a variable I, and you do like, hey, I'm going to iterate through all the possible lengths on this particular variable, which is s, and then we print x here. This is like for hexadecimal. And then what it's doing is you just take the s and like the index of I, right, which is there'll be 18 times, and you see the values here. right? So you have E0, which is an X decimal value, and then B8 and AA. And it's funny, you look here on the line 23, there is only 4 characters, but in fact that 4 characters, humanly perceived characters, I must add, it is able to save that as, 18 bytes. It's funny, like, the way that is storing it also depends on the encoding, which will go next very shortly, right? Actually, this is going to be the next one here. So the idea of encoding, right? So just a string by itself, it's pretty much meaningless. That's something that I would like you to notice. Actually, I need to explain that why, right? So let's go to the Go by Examples website first. So on this string and runes web, page, they have a few links, which is also on the codes there, and there is a link for a blog post. Okay, and I want you to read it. This blog post. I read it myself, and it's quite outstanding information that it has here. It's very important for us. But what struck my attention is a mention of another blog, which is absolute, and the title is, it's a very catchy title. Look at this. Absolute minimum every software developer absolutely, positively must know about Unicode and character sets. Parenthesis, no excuses. Wow. Just like, honestly, I've been working with software development for like a decade and a half. And honestly, I knew half of this content, but not like in detail, right? And this is something nice about Go, not just Go, but the documentation and some other things. You gotta know in details. Knowing just half is not enough, and this is a mindset that I would like to pass to you. Have that, right? Like, always know if you see a syntax, a package, or something that you don't know, research, debug, do POCs until you know it, and don't proceed with your task, your Jira story, and whatever you're doing until you got to know that. And you do that, eventually you're going to be a very proficient engineer. But in any case, here it is actually explaining a little bit more about the nuances between the encoding. This is Joel Software blog. And this gentleman here actually is one of the co-founders of Stack Overflow. Yes, you heard it right, Stack Overflow. He also founded a bunch of others. You see here more about me. He founded other software as well, like Trello, a task management, very easy to use with Post-it software, among other things. But just going back, I wanted you to read this, right? Read it. It's going to be life-changing for you, right? But I'll try to summarize. That's the purpose of this video. So let's go back here, right? So where we were right here. So the next one, it does a rune count, right? And I didn't tell you what a rune is yet. We know what a string is. A string is a combination, like typically speaking, a string is just a combination of characters that is saved in a variable, but we know that now in Go, that variable is in fact an array of slices. But what happened is a character, there is multiple nuances, right? So that is why the Go by Example team, they chose this word hello in Thai, because they want to be explicit about that. So if it were many years ago, and depends on your computer configuration, we might have seen this as a bunch of like question signs, because my computer might not have been able to interpret that. But fortunately, this is 2022. The capabilities is right there. The editor is able to understand the encoding and etc. etc. But what I'm trying to tell you is the encoding, UTF-8. Please make sure that you know what it is and why it's used. But the idea, just in a very simplified version, the idea is you allow your computer to interpret a character based on a specific code. So right now, even though we see this character right here, code-wise, it is being represented by an array of bytes, but by itself you cannot decode it, right? So that's why every time you're using a string, you gotta know what's the encoding. And the encoding by default on Go is UTF-8, at least on the editor side. There are more details on the links that are provided on the description below and on this blog post here as well. But again, I'm trying to simplify it. So the idea is you have the encoding, and the encoding of a character, it is standardized by an organization. And this organization is the Unicode Corporation, I think. We can actually go here on the link. Let me show you this. So it's Unicode standard. Yeah, but yeah, their organization, here we go, is at unicode.org. So that's the organization that, you know, specifies the standard. But what happened is when they are doing, you know, specific characters, in order for them to identify a character, they assign something, they created a concept that is actually called code point right here. So a code point, so every single character that you see that is a unit, not only like, you know, standard alphabetic Latin letters, but also emojis, you know, special characters in languages like, you know, Spanish or Brazilian Portuguese, which is my background, with accents. Each of those characters, they assign a specific code, right? And that's called code point. So for example, let's go next here. So we do a for each here. Actually, it does a len, right? Where's the next one here? Wait. So it does the yeah. So this one is just this array, right? And it does a rune count, right? So we have the concept of a code point. Code point is you see this right here. This letter U stands for Unicode. The plus sign is part of the syntax, and an hexadecimal value, right? So this hexadecimal value, it is a code that represents for this particular character right here, and that's the code point. So for example, you can actually copy this, right? There is a website which I will also post on here below. Let me not get this here. There's another example that I want to show you next. But if we search this here, in theory, here we go. We go to this Thai character, and the Thai character is for Sua. Sorry if I'm mispronouncing this, apologize. But the Unicode number for this character is this little guy right here. And if you go down below, it tells a little bit more examples on the encoding section. So that for the UTF-8, the hexadecimal representation of this character is E0, and then another one P8, and another one AA. The reason why there is a space is just the way the hexadecimal versus binary works, right? So like one hexadecimal character can hold up to 4 bytes. So when you have 2, it can represent not 4 bytes, 4 bits. So 2 characters here would be 1 full byte. So that's why you see 3 groups, which is represented by 3 groups of binary here. This is very high level. I'm actually going a little bit more detail than I wanted to, but this is important. Please research. This is an amazing website. I'm also going to put this link below. So going back here. So we know the code point, right? So the code point, so the code pointer for this character is this, you know, this code right here, which is an hexadecimal value. But Go introduce another concept called runes, right? So they don't want to call this just a code, you know, a code point, but they want to call it runes, because they added a little bit of more behaviors on the top, right? So, and this behavior, for example, right here, is just, every rune variable, it is an integer. Actually, I'm going a little bit more, too much details here. Let's continue here. So the idea of runes is actually they say that at the very top here. So like, you know, in Go, the concept of a character is called rune, which is an integer that represents a Unicode point. So this guy right here, in Go, we specify in a variable called the type of rune, which is an integer, and it just saves this value right here. We're gonna see a little bit more on how it actually works. Let's move on, right? But there is another catch in here, and which once again, it's why they chose the Thai language to represent it, right? But let's take a look. So they say, hey, the concept of a rune, in Go, the concept of a character is called rune, right? But look at this. You do a rune count, and it says 6. But wait a second. I'm no specialist in Thai language, but as we saw at the beginning of the video, each unit is one character, right? So like I'm counting here, I'm only counting 4. And they actually mentioned that on the comment section is the rune is actually the code point of that particular character. But it so happens that Unicode, they have another concept that they called a grapheme cluster, which is like, 2 characters together, they create another character, and they can represent differently when they do the encoding. It's kind of weird. That's why you need to read those articles there. But so, for example, look at this, right? So the first character here on the left side, on the right side, it just closer to the Latin letter A. But the second one, there is like 2 symbols, right? There is one symbol at the bottom, and there is another little symbol at the top. So in Unicode representation, this character is actually represented by 2 runes, right? So, and then it moves on. There's another character, and the same thing with this other one here. There is like a little 2 symbols there. Again, I'm no specialist in Thai language, but you see here the bottom section, and there is a little thing on the top that adds on the top, right? Which is also represented by 2 runes. So once again, Unicode, you can represent a character by multiple code points, but when the outcome can be a single symbol, right? So this will be 1. The second symbol is 2 values, so 3 so far, 4, 5, 6. That's why the rune count here is 6, right? Yeah. So this is just do a standard 4 range. This is another thing that I'd like to mention. When you do a standard 4, not using the range, you will automatically, iterate through the slice of bytes. But if you use the 4 range instead, what you're gonna use is, iterate through the rune value, which is closer to the concept of character, but not quite. Depends on if you're using emojis or special characters. This is very, like, if you're whatever code you have, it's just a standard like Latin alphabet, then this would work fine. But if you're using special characters, it will not work, right? Let's continue here. So most of the times you're going to use range to iterate through the characters, and there is a print here that I know you can print with a capitalized U to specify like what's the actual complete Unicode code point representation of that. And then here below, it introduced to us another package, which is called UTF-8, and it says decode, rune in string, and it say, hey, we're going to decode this. This is another representation of the 4 range. So you can do the exactly same way. Just do another one here, how we do the comparison, like you can use with just a single quote here. But I want to pause for a second, right? This is, to me, when I took a look at this, it was very complex, right? There is a reason why they chose those special characters. It's just because they wanted you to be aware about the encode and the Unicode and etc. But it's complex. What about just a standard vanilla use case that, North America or standard alphabets that we have, we are not going to encounter something like this. What's going to be the standard, right? And the safest as well. Safest to do, like if you're doing string manipulation, what's the actual safest to do that count? So in order to do this, I actually created another example that I would like to show you, and which is the strings grapheme right here. Right, and this is the code that I wrote it, so you're not gonna find on the go by examples. So let's just clean this up here. It is inside a grapheme folder. And by the way, grapheme is the actual official terminology for a character, like in typography or something, is the official dictionary definition. But anyway, let's not go much in detail in the actual terminology dictionary section here. So let's run it first, as usual, right? Go run dot. My proposal here. So we have the results here on the right side. Let's keep that in mind. So here's what we're gonna do. We have the value from the previous video, or from the previous, strings and runes variable right here, 4 characters, and I say print grapheme. So what I'm doing here is just very standard print. So first line I say, hey, I'm printing the details of like the string that you just specify on that function. And the second one is we created runes based on that string, right? So now we have an array of runes, which theoretically speaking should be each character, but we just know that is not, right? And then I just printed the rune just because, and then those values right here, and then we do the length, the length of the runes, which is 6. But now we're gonna do something using a third-party package. The link will also be on the description below, which actually does the count of the graphene cluster. So what does that mean is in the Unicode, and this is like the standard Unicode representation, when you are able to do multiple characters and combine them to have one single representation of a character, this combination, this grouping is called a grapheme cluster. Go right now does not provide this capability to count this by default. That's why we're using a third-party, package. But in fact, even on the Go website, I think they are actually mentioning this. Not on the Go website, on the Stack Overflow anyway, which I'm also going to provide the link below. But let's take a look at it even further, right? So what I'm trying to say is this grapheme cluster count is the safest way for you to do a count of characters that, ignore like the special characters and like the Unicode and whatnot, right? So, and this is what it does. And I created a few more examples to specify, to highlight that even further, right? Which is with emojis, right? Like with special characters, we're not going to encounter like, foreign language characters very often unless you're, you need to. But emoji is something that we can, relate a little bit more, I think, at least here in North America. So for example, we have here a thumbs up emoji, right? So it's funny. Let me copy it. Actually, I don't need to copy because I have it open. So an emoji is a standard by Unicode. They have a Unicode assigned to that emoji. That's why when you can copy this, you can paste it. Like your browser understand because it's a normal character, right? That has an encoding into it, right? And it's funny when I copy this and I paste it, my editor is able to identify because it understands the encoding value and it understand on how to represent this through a font. There is a font called Cascadia. The link on how to set it up will be on the description below. But this font, Cascadia Nerd Font Complete, is able to represent the thumbs up like this. So why am I using this example? Same thing, I printed this on this function, right? And then we have here, printing the details for this. For this thumbs up, it only has one rune, right? So one Unicode code point representation. So when we do a rune's length, it's safe, it will always return 1, and the grapheme cluster will always return 1. And for this, I need to zoom in, right? Let us zoom in to make sure that you are able to see the differentiation in color. Look at this. There is a skin tone difference on this emoji. This emoji is more like yellowish, and this more, I don't know how to describe, just different tone, right? And this one is a different character. But it just so happens when the same as the Thai language here, the rune representation for this emoji is actually 2 runes. And there's a catch here. My terminal is unable to understand the second rune. It is unable to understand into a single character, and instead it prints the same color here, thumbs up, and same here. It's funny that on the left side we see the skin tone difference, but on the right side we don't. This is a bug on Visual Codes, okay? And I'm gonna prove that to you. I have a terminal open right here. So I am on the same folder. I'm gonna just run this code, which is the same thing on here on the left side. So when I run this, same output, but in this case, my terminal, which is a Windows terminal PowerShell, and I set it up like I customized a little bit, but is able to understand the skin tone right here, right? There is a difference in skin tone. But here, the bug on VS Code is, even though it's an integrated terminal, it's unable to understand that. So it was nice to do this on this video so I can actually show that, you know, that difference. Yeah, so once again, this particular skin tone, actually, if you copy this, look at this. If you copy this and you paste it here and you click, you're gonna see that this is an emoji modifier, right? And there is a skin tone, and you go on here on the description, is a medium light brown modifier. Medium light brown, that's the name. Medium brown light modifier, which is used as an application to human emojis in order to indicate their skin tone. So presumably this is used for, like, you know, face emojis, or maybe like thumbs up emojis, or different hands emojis, right? Or thumbs down as an example. So yeah, so in order for the Unicode representation is the thumbs up Unicode plus the skin tone modifier, and it has 2 rooms. And once again, if for some reason you are coding in an application that needs to save a thumbs up, which should be fine, right? Like, you know, it should be okay. Then if you need to do a count on this, once again, the safest way is to do a grapheme cluster count. Again, I acknowledge that this what I've explained here is in a very high level. If we were to explain in detail what actually this means and why, it will make a much longer video. So please do your homework. Take a look on the links that we got provided here on the description. Read the, you know, the catchy blog posts here, the absolute minimum that every developer must know about, you know, the Unicode and the character sets. Read those 2 and you should be fine. And that's pretty much it for today. Thanks everyone for appreciating your patience. If you like it, please like the video and subscribe it as well. This has been an amazing journey, and I hope you are enjoying the content. And that's everything for today. Thank you very much. See you next time.